Hello, 20-1s. Lesson today, quad functions. We're going to talk about how it works on the calculator. Earlier on lesson 1, we talked real quick about that. This is going to give us a little bit more information. You should have the graphing quadratic functions on a calculator handout to refer to. It's all summarized on there. So this is supplemental. This isn't in the booklet. If you don't have the handout, jot down this information. Grab a piece of paper, it's blank, put the title down, and figure it out. We're going to go through it fairly quickly because this is not information that's new. You should know how the calculator already works. We're just going to review it. So here we go. Graphing functions on a calculator. First things first is we have now talked immensely about our vertex form. What you have to understand is the vertex form is nice as long as numbers are whole. But sometimes if you have a question where you maybe have y is equal to 7/9 bracket x minus 2.76 squared subtract 17/19. I mean, technically you can get the information, but actually seeing it can be tricky. So there are situations where doing it on a calculator can be beneficial because also we can get it on the calculator and get information off of it if it's not nice whole numbers that we're working with, which is reality. So here we go. Real quick, we've already talked about this, but we always want to start top left of the calculator, the y equals button. This gets you into the graphing area of your calculator. Second thing, that button, it's got an X, a T, a theta, and an N on it. It's an actual button. That's what you hit for your variable. You then have in the top right the graph button. That's how you take from your y equals, you punch in, helped with that, you hit graph and your graph appears. The last button actually that I don't have on this page but is maybe beneficial, and I have talked about it earlier, is your negative button. It is so important that if I had y equals -7 bracket x minus 6 squared plus 2, this is a negative sign. You need to use the negative button for it. If you just use the plain old subtract button, it won't work. This is your negative button. X minus 6, that's your subtract button. If you hit negative, now a subtraction sign is like a -6, but this is saying x minus 6. It's important you use the correct buttons, otherwise you get frustrated because the calculator says it can't be done, and really, it can be done. So, very quickly, can you please graph those particular quadratic functions? What's important though before you do that is I want you to understand is that you can do this when you have your quadratic function in vertex form, even with a fraction, and we'll talk about that. You can put it when it's in vertex form, but this last one, we don't have vertex form. But because it has that x squared in it, we know it's going to be a quadratic. Even if it's not vertex form, if I punch this in, I can still end up with my quadratic function parabola. So let's put these into our calculator, pause the video, and start substituting into your calculator. So we go into the calculator. I still have stuff from another lesson I was doing, so I go into y equals, top left button. I want to clear what I have in there. Use my scroll buttons, get on top of them, scroll and clear it. And now here we go. Our first one was 1/2 bracket x minus 4 squared subtract 3. Now 1/2, a lot of you will just write, oh, that's 0.5. I can substitute that in easily instead of 1/2. But let's remember, we can still put fractions in. Bracket for a fraction and the division. 1 divided by 2 in brackets. There's a half. So I want 1/2, and then I want the bracket x minus 4 squared and so on. So we have x minus 4 bracket squared. So we have the 1/2 in brackets, and that 1/2 would multiply by this x minus 4. So that's why we have then x minus 4 in brackets as well. Use your brackets around your fractions. And then we finished with subtract 3. We should be able to graph that. Boom, there we go. What we know, x minus 4, p is 4, q is -3. Our vertex, we don't know for sure, but it is at a 4, -3 area. 1, 2, 3, 4. 1, 2, 3. You know what? There's our vertex. So our graph, really quick inspection, it's opening up because a is a positive 1/2. Actually looks like it is maybe a little bit wider than just y equals x squared, which it should be because it's a 1/2 a value. So it works nice. Next one, real quick, make sure we know what we're doing. We want -2. Make sure it's a negative that you hit, not subtract. If I just go down and I see that I put in subtract 2 by accident, you'll notice that a subtraction is bigger, the negative is smaller, and it's even raised a little bit. So if you're looking, saying, how come this isn't working? Look to see, did you hit subtract or negative? So from there, -2. Well, I don't want that one anymore. I want to go back up to y1. So -2, bracket, x plus 3, bracket, squared, plus 9. Taking a look at this, what do we know before we actually hit graph? Well, we know that our p-value is -3, q is 9. So -3, 9, vertex should be in the top left second quadrant. We also know that our a value is -2, so we should be opening down. Let's see if it worked. There we go. Quadrant 2 vertex, opening down. At least we're on the right track. Not sure yet if it's perfect or not, but I'm pretty sure it is. So last one, important with this last one, something about it I want to talk about. We have again -3 x squared minus 32x plus 18. So we don't have vertex form. Like I pointed out, that squared tells us that we do have a quadratic. So now I graph. Doesn't look like I have a quadratic. However, just because my window settings aren't correct, we can see on this that it doesn't match up, but we have two things as this is heading. So really, two things could be happening. It could be going down and then should be coming up, or it could be going up and then heading down. Well, maybe you do know, maybe you don't. What we need to do is we need to change our window settings. So we want to go higher and lower. Higher, that's a change on our Y max value. Lower is a change on our Y min value. And again, we don't know if it's going like this or if it's going like this, so we need to change the other values as well. And what are those changes? Well, if I want to go further to the right, that's the X maximum direction. X-axis to the positives. To go further this way, that's X-axis, but to the low values. So I want to change all of my settings. So quick review, you want to go to window button along the top row of things. I want to change my -10. I don't know, let's go -50. X max, 50. Make sure you have the correct sign. Sometimes students will miss and they'll actually switch and put an X max negative, X min positive. Calculator is going to implode on itself and say, will not work. Make sure you've punched things in correctly. Y min, let's go -50 y max positive 50. I do have students at times that when they do this, they just punch in x. They'll punch in like 40,000 for all of them and negative 40,000. No, you need to know how the window works effectively. Let's graph that. All right. What do we see? Well, at this point, we see that it is actually have an x max point the way it's opening. I have way too much here and way too much here. So I want to take my x max and my x min and make it way smaller. Do I need to see all this down here? I don't. My y min values, excuse me, my y min values I can bring up as well. But my y max, we can't see the vertex yet. So my y max needs to go higher, but everything else can be made smaller because I don't need to see all that. So let's go back to our window. Erase that what I had. So what did we want to do? Our x min doesn't need to be that big. I'm just going to go down to negative 20. X max didn't need to be that big. I'm going to go down to 20. My y min didn't need to be that low. I'm going to go down to negative 20. But my y max, we weren't high enough. I'm going to go up to 100, see how it looks. And I'm going to graph that. Now we can see better depiction, except we still don't see that vertex. Our vertex is still a little higher. So let's quickly go in one more time. Window, we want to go y max. Let's go to 120. Graph it. There's a better depiction. Good window settings for this particular graph. What do we notice? We notice that it's still a graph that's a quadratic function, gives us a parabola even though it's not vertex form. So using the graph effectively is important. I'm just going to go back and change my window settings to all the 20, which is a fair default, not a problem. Didn't help for this one, but that's okay. All right. So here we go. Let's take a look at what else we want to try to do with this. The other information using our graph is we can identify some key components from the calculator by following certain functions. If we want to identify a vertex, we can't see it specifically. Maybe it's not whole numbers. What we want to do is we want to graph it. Once we've graphed it, we hit the second trace button. Second and then trace. This is going to be an important situation for all these graph functions. But my vertex, remember, the vertex could be a max or a min. So once I hit second trace, I need to choose 3 minimum if it's a minimum. I need to hit the number 4 maximum if my vertex is a max. So I have to know what's going on. And then we use the arrow keys at the top to follow the prompts that it gives us, which I'll walk through. So we have in this case, we want to graph negative 3x squared minus 7x plus 4. We want to graph 2x squared minus 5x plus 1. And we want to find the vertex for each. So let's walk through it. Calculator, y equals, first graph, negative 3x squared minus 7x plus 4. Let's graph it. Now, it's not absolutely perfect for a window setting, but I have all the key components. It's not, I could maybe bring my x's in a bit, but I'm not overly concerned. It's fair. What were the steps for vertex? Second function and trace at the top. Now I have my choices. Because this quadratic function opened down, we actually want to choose then the vertex, which is a maximum. So we hit enter. Now here's where you have to be careful. We have the cursor. The calculator prompts left bound side. So I want to move my cursor, if this is my vertex, I want to move my cursor first so it's on the left side. The second prompt will be right bound, so where it is would not be bad for the right. but we have to start by doing what it asks. So move using the arrows to start with on the left side of the vertex. Keep it close to the vertex for accuracy. Hit enter. Now it says, can you please go right bound? So we see that we have a setting on the left. Move to the right, hit enter. Calculator saying, would you like me to guess the vertex? And we're like, enter, please do. Yes, that would be great. So our maximum point, rounding to the hundredths place, negative 1.17, 8.08. There's the vertex for this particular graph. It wouldn't be easy to do if I didn't have the calculator. Those would be ugly calculations. So let's try the second one. Let's go to y equals. Let's clear that. The second was give this one a try on your own, and then we'll do it together. So give it a try on your own first. What do we want? 2x squared minus 5x plus 1. Graph it. All right, it's decent. Fits nicely onto my window display. I could maybe shrink it up a bit, go down to 15s or 10s, but 20s is fine. I want to know where my vertex is, but take note this time my vertex is a minimum because my graph is opening up. So what do I need to do? Second trace. We want number 3, the minimum in this case, because it's not a maximum value. Hit enter. Please, again, note that it says left bound side, so we want to scroll so we're close to the vertex to the left of it. Here's our vertex, cursor's to the left. Then it's going to ask for right bound, so then we want to be on the right side of it. So from there, hit enter, left side, yes. Now we want to be right bound. Yes, guess it, please do. And in this case, our vertex is at negative 1.25, negative 2.13. So easy to find a vertex. If you practice it, it's a no-brainer using the calculator. Next thing we can do is we can identify the y-intercept. Y-intercept, we talked about it. To be honest with you, it's easy in some cases, but the y-intercept happens when x equals 0. But we can get it on the calculator. Again, second function, trace. This time for y-intercept, we want a value, and it says, well, what value do you want? We want it when our x is 0. So there's what we have to set in. We are using the same functions. So again, have the negative 3x squared minus 7x plus 4. Graph it, and let's follow the prompts. Y-intercept, second trace, number 1. We want, number 1, the value, so hit enter, and we want the value where x is equal to 0. So when x is 0, hit enter. That's telling us when x is 0, our y is 4, and that's where we're hitting the y-axis. Pretty straightforward, I hope, I think. So you try the next one. Give it a whirl and see what you come up with. That's 2x squared minus 5x plus 1. Can you come up with the y-intercept? There's my graph, y-intercept. We want to know exactly what point is it hitting that y-axis. So we walk through, second function, trace. We want to know the value 1. I don't have to scroll, I can hit the 1 on the keypad. And we want that for x equal to 0 because our y-intercept always happens there. Hit enter, and in this case, our y-intercept is at 1. Not rocket science, but you do have to practice a couple times so that you can remember the keying process. Last one is to actually identify, this is the x-intercepts. Shame on me. We want the x-intercepts. Now remember, we talked about this. Right now in this unit, x-intercepts, all we're trying to do normally is identify how many. But with the calculator right now, you should be able to calculate what they are. Can't do it algebraically, but the x-intercept is fair game with your calculator. Second trace, that's not new. This time we want the zeros. X-intercept happens somewhere on the y-axis, so we want it when x is 0. That's kind of how I think of it. And then we use the key prompts. So go to your calculator. Here we go. What's, again, negative 3x squared minus 7x plus 4. Graph it. Okay, this time I'm actually going to change my window settings so I can see the x-intercepts a little better. So I want to bring my x minimum in. I want to bring my x maximum in. You know what? And I can even bring my y minimum values up. So I'm going to change those window settings a bit. So my window settings, x min and x max, I'm going to bring into 10s instead of 20s. And my y min, I'm going to bring up to 10 instead of negative 20. If I graph it, okay, now I can just see those a little better. Now, this can be a little tricky for students, and here's why. It's going to prompt us. We have to do each x-intercept individually, one at a time. It's going to prompt again, left bound, right bound. What you have to understand, if that's my x-intercept, if I want left bound, I want to be on the left side of my x-intercept. In that case, where would I put my cursor? My cursor would have to be below because that's going to move me a little bit left. But you have to be careful because if we're working with the other intercept and we have to be on the left side, well, to be on the left side of that intercept, we actually have to put our cursor slightly above because going above moves us left. Whereas for this intercept, to get to the left of it, we actually have to go below. So it takes a little bit thinking, not quite as straightforward as some of the others. So let's walk through and see what we can get. What do? Second trace. We want number 2, the 0 values, but I have to work with the intercepts individually. Habit, I always go to the left intercept first. So we want to be left bound. To be on the left side of the intercept, my cursor needs to be a little below. Because as I move below, I'm also moving left of the intercept. So try to be close to it, hit enter. Now it says be on the right side of it. So every time I move up, I'm moving right of my intercept. So in that case, I want to be a little closer to it, but on the right side of it, hit enter. Guess it? Yes, please do. Enter. So our first intercept is at negative 2.81, and then you have this. This negative 1e negative 12, that means we have negative 1, but we really want the exponent to be 12 to the left. So if I move my decimal 12 times to the left, that would be 0.0000000 negative 1. This is just saying 0. Learn to recognize that. You'll see it in scientific notation when in some of your science classes, physics especially. So our first intercept is at negative 2.81, 0. Negative 2, almost to negative 3, and 0, that's our intercept. And now we can get the other intercept. Have to walk through it again. Second trace, we want the 0. So now we're going to go to the left, or sorry, to the right intercept. We want to be left bound, which means I have to be above it. Because as I go up, I'm also moving left of the intercept. So left bound, be close to it though. enter. Right bound, be below it, enter. Please guess it, 0.470. This case, our y was nice and 0, didn't have to overthink it. So does that make sense if I just move my, cursor out of the way? Sorry, we can see negative 0.47, or sorry, 0.470 is about where that is. So we're okay. So there we go. I'm not going to worry about another example with just on the x-intercepts. Let's take a look at a different top to bottom, start to finish. 10x squared minus 15x minus 25. So 10x squared minus 15x, 10x squared minus 15x, and was that plus or minus 25? Minus 25. There's our graph. Not vertex form, but it is a quadratic because of the squared. We graph it, have to change our window settings. We can see, hopefully, that this is narrowing, so we have a minimum point that we need to see. So what do I need to do? I'm going to bring my y minimum down. I don't need that much y max, so I'm going to bring that down as well. So my y min and y max, y min needs to be brought down further. So I'm just going to go to negative 30, make sure I hopefully see it. My y max doesn't need to be that high. I'll bring it to 10. Not quite. I could still go down just a hair with my y min. I'll go to negative 35. There I see all the points I want. Vertex, y-intercept, x-intercept. Walk through it really quick again. How do I get my vertex? Second trace. In this case, it's a minimum value. Enter. Be on the left side of the vertex. Enter. Be on the right side of the vertex. Enter. Guess it. Our vertex is at 0.75, negative 30.63. Tough calculations to get on your own, but the calculator can do it for you. And what? Second trace. Now we want the y-intercept. That's our value. Number one, we've got it. We want to know when x is 0, which will give me my y-intercept. Whoops, I didn't want graph, my bad. Second trace, we want the value 1. When x is 0, hit enter. Our y-intercept happens when x is 0, and we hit the y-axis at negative 25. And the last one, second trace, we want the zeros, our x-intercepts. So I need to scroll up to the first intercept. Again, left bound, so I need to be above it. Enter. Right bound, I need to be below it. Enter. Please guess it. Our first intercept is actually at negative 1, 0. Second intercept, second trace again. Again, we want the 0 value, but now we need to scroll over to the right intercept. And from there, we want to be on the left side. So if I'm below it, I've moved to the left of it, enter. Want to be on the right side of it, enter. Please guess it. 2.5, 0. So we can get good information off of our calculator. So in terms of an assignment, I'll be honest with you, that handout, you can practice this as much as you want. Just find some functions, some quadratic functions, and play with the calculator a bit. The key here is that the calculator is only allowed at times. The calculator can do calculations, but anytime a question says algebraically, you can't just punch it in the calculator and solve it. This is showing knowledge, not of the calculator, but of the processes. What's great though is even if a question says algebraically, I can show all my work, get my answers, but I can always plug this stuff in the calculator to see if I'm right. So the calculator, if a question doesn't say specifically algebraic, calculator's your friend to calculate information. But even if a calculator says do it algebraically, or if question says do it algebraically, we can do it, but do a check. Know how the calculator works. It's going to be beneficial. See you next time.